which is to calculate how many civilizations are in the galaxy around us. Which sounds really cool. But it is very much, calling an equation a bit of an exaggeration. It's a guess. But this is the equation down here. I'll quickly skim through it. Now, I will put my own numbers into it, and I will work out what this number is, n, the number of civilizations in the galaxy at the moment. I will get my own estimate for that. It may not be what you think, and feel very free if you will scribble this down, go home and look up your own. Especially look up your own numbers. Most of these numbers you have to make up. But let's just go through it. So the first thing number you need is actually one of the few numbers in this equation we actually have a value for. The other thing here called R star, which is the rate. It's basically how many stars are formed in the Milky Way every year. And the best estimate of this is about 7. And this photo here shows one of these great clouds of gas and dust that stars form in. So let's stick 7 into our equation. How many planets out there? Well, we actually have a handle on this now. If we were doing this 20 years ago, we wouldn't have. But now we have actually observed other stars, we have a good idea the sort of statistical frequency in which planets occur. And basically it seems like about 40% of stars have planets going around them. So we can stick a number in there, we can stick 0.4 in. Well, if you see what's going on here, we're multiplying these together. So we're multiplying 7 by 0.4, so we've got 2.8, which isn't sounding too good. The next one is how many planets like Earth are in each solar system. And by that I mean planets in the Goldilocks zone. Now, there's a brilliant satellite mission called Kepler up there at the moment, which is finding exoplanets. And based on data from it, if you look at the data in the most optimistic way, it looks like about a third of stars have planets in their Goldilocks zone. Now, that is an optimistic look. You look at the same data and get much smaller numbers from it, but we're being optimistic here, so we'll stick 0.34 in. And now this is where you really have to start guessing. Basically, how many planets in each solar system have life on them? And we have no idea. In our own solar system, there's one planet with life on it. We have no idea how often life actually arises. We do know, however, that life started very soon after the Earth cooled down, so that seems to suggest life can arise pretty easily. So let's just say every planet in the Goldilocks zone, life arises on. I personally don't believe that, but let's stick it in. And then, how many of these planets have life on them does intelligent life arise? Now, again, you just have to guess this, because we've only one planet we know of life on, and it doesn't mean intelligent life on it. But, on the other hand, most of the time there's been life on Earth, there's been no intelligent life on Earth. Most of Earth's existence, in fact, it's been the bacteria that live on Earth. So I'm just guessing a number here. I'm saying on the 10th of planets, intelligent life will arise. And I have no evidence for that. I'm just sticking it as a number. Let's do another really hard one. Another guess. How many civilizations out there actually develop radio astronomy? This, I should say, that Frank Drake was a radio astronomer, and he assumed the most intelligent beings in the universe would be radio astronomers, which is an interesting example of bias. So let's say that a tenth of civilization in the universe eventually developed radio telescopes, and finally we get to the most problematic bit of this little equation. How long does a civilization last in years? For a civilization invents radio astronomy, how many more years will exist? We have no idea. We invented radio astronomy 80 years ago this year, so we could stick 80 in this equation. But let's be optimistic and say we'll continue being civilized for another 1,000 years. That might be pessimistic, I don't know, but let's take it anyway, and let's do the calculation. And it just worked out that there are 9.5, that's around 10 civilizations in the universe. So this is a sort of statistical process astronomers use to say if there is life out there. You could argue all night about is this valid, but there's me and some of my friends out there. So anyway, so it's not a totally stupid idea that there could be other civilizations out there. But I said about traveling between the stars. Now, stars are hugely far apart. I sometimes when I have more time, I'm doing a talk like this, as I go along, I make a little model of the solar system where the distance from the Earth to the Sun is 1 inch, and they measure and so on, have great fun sticking marbles on it and putting all the planets out to scale. If you, on that scale where the distance between the Earth and the Sun is 1 inch, you want to put the nearest star in, well, you have to walk 2.5 kilometres down the road. Stars are very, 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 very far apart, and it will take a very long time to travel between them. At the moment, the fastest spacecraft human race has ever built is on its way to Pluto. It's a little unmanned spacecraft about the size of this desk here, called New Horizons. It was launched in 2006. It'll get to Pluto in 2015. It would fire it at the nearest star. It would take about 63,000 years to get there. But one of the other things which does sadden many people is, as a science fiction fan, sadden me too, is this bloody idea of travelling faster than the speed of light seems to be totally impossible. As far as we know, the speed of light is Einstein's speed limit. Nothing travels faster than it. So we're talking about journey times of decades to travel between stars. Now, some real scientists have came up with ideas about how we could do this. You know, we're going to just accept years of travel. I'll just quickly run through some of these. I do stress these are not like science fiction. These were dreamt up by serious scientists. This thing here is called Daedalus. There's an organisation, it's actually very interesting, it's well worth joining, called the British Interplanetary Society. It's for space enthusiasts. And about 30 years ago, they came up with this idea for a spaceship you could send to a nearby star. And basically, it's a giant probe. It's nuclear powered. It's powered by nuclear fusion, the same process that powers the sun. And you would build this thing, and I have to say it is enormous. It's about the height of the Statue of Liberty. You have to build it in space because it would be too big to take off from the Earth. And you point it towards a nearby star. It will reach a tenth of the speed of light. So take maybe 40, 50, 60 years to get to a nearby star. And they reckon with sort of technology we might have 100 years, we could probably do that. But still, a journey time of 50, 60 years, even if the nearest star is great. This thing here has actually been experimented with. This is called a light sail. It's a very strange thought indeed. But light actually exerts a very faint pressure. If I stand up in front of this projector here, I don't feel it, but the light is actually very, very gently pushing me backwards. The pressure is very, very faint. But we do see this happening in space, where these great nebulae, great clouds of gas and dust, we see how the light sun, the light of stars in them, can push the gas and dust around over very long times. This spaceship concept is an idea you can make a huge sail out of fantastically lightweight foil and strap a little spaceship to it, and sunlight will push it along. The advantage is it goes very slowly at first, but there's nothing to slow it down. So over the years, speed builds up. So it's actually going very, very fast indeed. And this principle has actually been tested on a small scale, and it is actually feasible. And you could use a variant of this to travel to a nearby star, although you'd have to use augment sunlight with a really light on the laser beam. This one here, funny enough, I think is the least feasible. This is called a generation ship. This is the idea if you really, really, really do want to send people to another star, well, you build an absolute gigantic spaceship. I say gigantic, we're talking city-sized. And you get at least 1,000 people as crew, get them all in, sail them into it, they press the button to take off, and it sets off, and it does indeed take hundreds of years to reach its destination. And in that time, the original crew live out their lives, have children, raise a new generation of crew members who will continue operating the ship, create another generation. Basically, if the great-great-grandchildren of the original crew who set out arrive at the target star, I have to say, I can't believe anyone would ever do that. I mean, it sounds like a crime against humanity. I mean, the only reason why you want to do that is one of these sort of giant asteroid going to destroy the Earth type situations. Right, this last one is a really neat idea. I've mentioned a couple of times here about the nebulae, which are big clouds of gas and dust in space. Some of the material in there is hydrogen, which is a great nuclear fuel. It's fuel that powers the sun and other stars. And this is a thing called the Bussard ramjet. Bussard was an American scientist. He came up with the idea. The idea is he built a spaceship with a huge scoop on it, which, as it flies through space, scoops up this very, very thin hydrogen gas which is scattered between the stars and uses it as fuel to push itself forward. So it's a spaceship that doesn't need a fuel supply. It's constantly gathering its own fuel. And that means it can keep on accelerating forever and become very, very fast indeed. All neat ideas, but one thing you will note, all of these will take decades or centuries to reach a target star. The idea that people will ever get to the USS Enterprise and arrive in a few weeks at another star seems very, very unlikely. The easiest way to search for civilizations out there is to listen for radio signals. And this is called search for extraterrestrial intelligence. And it is something I have a lot of skepticism about because it assumes that everyone else in the universe is a radio astronomer and who's actively trying to broadcasting signals. We, as a race, don't do that. It doesn't seem that likely that our civilizations are. But maybe, I'm sorry, there have been lots of searches for radio telescopes, and there's no conclusive evidence that ever came from them. But let's talk about, get back to the subject of UFOs.